नमस्कार दोस्तों, कैसे हैं आप लोग। आज मैं आपको एनालॉग टू डिजिटल कन्वर्टर के क्वेश्चंस कराने जा रही हूँ। मैं यहाँ लास्ट से शुरू करती हूँ। फर्स्ट क्वेश्चन है द रिजोल्यूशन ऑफ ए डैक। DAC means what? Digital to analog converter is R bits, right? And the maximum output of a DAC is V volts. The maximum output is V volts. Then the weight of the MSB, most significant bit, is C. Resolution is mainly the smallest change in the input. Okay, resolution is it means actually step size. Okay, the change in the size of the steps. The resolution or step size in DAC, that means R, number of bits. Number of bits. That means you can say एनालॉग आउटपुट जो आपका वेटेज होता है, एक्चुअली इट इज आस्किंग दी जो फॉर्मूला है आपका वो होता है कुछ V आउटपुट इज इक्वल टू V बाय 2 टू द पावर R माइनस 1, 2 to the power R minus 1 BR minus 1 plus 2 to the power R minus 2 BR minus 2 plus minus and so on. So जो वेट ऑफ MSB होता है इसका फॉर्मूला होता है 2R minus 1 into V by 2 to the power R minus 1. This is actually formula. ठीक है, तो ये आपको याद रखना है. ओके, ठीक है. नेक्स्ट क्वेश्चन है आपका an n-bit DAC is desired to change in 1 millivolt increments while using a reference voltage of 5 volt. The number of bits required for the DAC is C. Resolution of DAC is given by V reference by 2 to the power n, right? Since n-bit DAC, the number of bits is n, it is given in the question. It has how many steps? 1 millivolt is steps. That means the number of steps is 1 millivolt. So you can write it as here 1 millivolt is equal to reference voltage is how much? It is 5 volt. This is your reference voltage. So this is equal to 5 volt by 2 to the power n. Okay, which implies 1 millivolt is equal to uh, as you can see what I can do 1 minute 2n is equal to 5 volt upon 1 millivolt. So 1 millivolt is equal to 1000 volt, right? And this is 5 volt, so it is around, or I can convert it in millivolt. That means if 1 millivolt is equal to 1 millivolt is equal to 10 to the power minus 3 volts, right? So it is actually it is 5 by 10 की power minus 3 volts. That means it is 5000 volts. It is 2 to the power n is equal to 5000. So n will be how much? N is equal to how much? It will be 13. That means it will come out to be as 13. Okay. So you have to write down the formula that resolution of DAC is equal to V reference by 2 to the power n. Okay. Now, next question is for a 10-bit digital ramp ADC using 500 kilohertz clock, the maximum conversion time in, it is actually asking the maximum conversion time in microseconds. See, the maximum conversion time, what type of ADC is given? It is digital ramp. So, maximum conversion time of ramp type ADC is given by 2 to the power n minus 1 into t, right? Since the frequency is inverse of time period, so I can write it as maximum conversion time is equal to 2 to the power n minus 1 into 1 by f. So this is 2 to the power 10 minus 1, okay? And what is the frequency? 1 by 500 into 10 cube. So if you will calculate it as 2 to the power 6 into 2 to the power 4, it is 16, and it is how much? 64. 6 carry 16 and 96, it is around 1006. Okay, so 1006 minus 1, it is 1005 by 5 into 10 ki power minus 5. Okay, So it will come out to be as 5 2 ja 10, 0, 5 1 ja 5. Actually, you have to con- uh, the answer is about to be 2046 microseconds. Okay, you can calculate it in your copy. Okay, 2 to the power 10. It is around see 2 to the 8 into 864 into 16, 16 4 ja, sorry, 16 4 ja 64, 6 carry, 16 6 ja 96. It will be 1003, I think. Yeah. So it is 5 2 ja 10, 0, and then 0, 5. Something it will come out to be like this way. So you have to write the answer. Next question is, okay, this is the input voltage Vi ranges from minus 5 volt to plus 5 volt. The figure shows a sample and hold circuit using a MOSFET. Okay, this is a MOSFET. Okay, and it is using this MOSFET as a switch. The threshold voltage of the MOSFET is 2 volt. It has zero leakage current in the off state, assuming that the capacitor is ideal. So, which of the following is true? See, the given MOSFET is, it is NMOS. The given MOSFET is NMOS, right? And V substrate voltage will be therefore positive and equal to supply voltage, right? Equal to supply voltage. So during sampling, what it is happening here, during sampling, MOSFET must be on. Okay. During sampling, MOSFET must be on. So VGS must be greater than equal to how much? Threshold voltage. That means Vg minus Vs should be greater than equal to threshold voltage. This is your threshold voltage. So put down the value here, 2 volt, right? So it is Vg minus Vi greater than equal to 2. For the maximum value of Vi, for maximum value of Vi, it must be on. So Vg minus, actually input Vi is input voltage. So it is ranging from minus 5 to plus 5. So Vg minus 5 greater than equal to 2. So Vg greater than equal to 7, right? Now it was all during the sampling process. Now during hold process, what it is going to happen? No. During hold. During hold process, MOSFET must be turned off, and for this VGS must be equal to VT. That means it is equal to 2 volt. So that means VG minus VS less than equal to 2, which implies VG minus VI less than equal to 2, which implies VGS is maximum for minimum value of Vi. For this value also MOSFET must be off. For this value also your MOSFET must be off. So that means Vg minus 5. That means if Vi is, it is ranging from minus 5 to plus 5. But this Vi equal to minus 5 will be taken here during off condition, when it is during hold. So Vg minus 5 less than equal to 2, which implies that Vg plus 5 less than equal to 2. So Vg less than equal to minus 3 volt. So what is the answer? That the value of V sub during sampling, uh, see, the value of Vg during sampling is greater than equal to plus 7 volt. Yes, it is coming out to be as plus 7 volt. Okay. And what it is given here, yeah, one more thing, the value of V sub during sampling is there any, the value of substrate voltage, see, substrate voltage will be equal to the supply voltage, as I have already told you. Okay, that means it is equal to 12 volt. It is equal to 12 volt. This substrate voltage will be equal to supply voltage, which is 12 volt, and which is absolutely correct. So the answer will be this first and third option. Okay, now next question is, see how many questions I have calculated. One, uh, two, three, four. Okay, so I have told you four questions. So first of all, let's not make it so lengthy. So Please like, share, and subscribe. I will tell the next remaining questions in the next video. Thank you very much.